Okay, so today we're going to look at vectors again. Just a quick recap. Remember, vectors are lines of movement. So if that was your vector A, it's a line of that length going in that direction. You can have a line going in the same direction that is twice as long, which would be 2A. You could have a vector that's half the size going in the same direction, would be a half A. You could also have the vector going in the opposite direction, which if it was at the same angle and the same length would be minus A, okay? So quick recap, if I had a triangle and I said that was vector A going that way and vector B going along here, if I wanted to know what the vector in that direction was, I could think, well, actually, I'm going along that line and along that line to get from here to here. So the vector for that would be A plus B. Equally, I could have something like this where I've got a vector going from here and a vector going from here, and I've got A and B both coming from this point at the top. If I wanted to know the vector along here, I have to think, how do I get from here to here? Well, what I could do is I could go up there and down there. And in that case, what I'm actually doing is I'm going minus A plus B. And a better way that we tend to write that is B take away A. Okay? So, a bit of the basics of vectors, which we have covered in class a bit. So hopefully that quick recap was enough. If not, let me know. So we've got a problem here, and it's not a rectangle. Sometimes you might be told it's a rectangle or a regular shape, and in that case you would be able to make conclusions about opposite sides and things, but in this case we're not told any information, so it might look like a rectangle, but you can't make that assumption at all. And they want us to find the vector PS. So let's have a look at this one first. PS. So what that means is I want to go from P to S. And obviously at the minute the direct route doesn't have a vector on it, so I need to go a different way. And the way I can go with vectors that I know is to go from P to Q and Q to S. So if I get rid of those for a second, what I want to do is I want to go from P to Q and Q to S. And when I do that, going from P to Q, well, I'm going in the opposite direction of A, so that's going to be minus A, and then Q to S is the vector C. So as I say, we tend to write that as C minus A, but both are correct. You don't have to write it in that way. Both are mathematically correct, it's just we tend to. So let's look at the next one. So the next one, we're going from R to P. I need to get a path that's going to go from R here to P here. I could do that, but unfortunately I don't know the vector TP, so that's no good. I need to go along paths where I know the vectors. So if I do that one, I do know those two vectors, so that's the way I should go. So let's get rid of some dots. So what I'm going to do is RP is going to be RQ plus QP. And RQ, because we're going in the opposite direction of that B, is going to be minus B plus A. So again, nicer way of writing it is A minus B. Right, next one. So let's try and move this down a bit because I'm getting a bit cramped here. Oops, I've lost my T. There we go. So, PT. Where do I need to go? I need to go from here to here. Can't do the direct route. If I go all the way around, I know the three vectors, so I can quite easily do that. So my PT is going to be PQ plus QR plus RT, and that is quite simply minus A plus B plus D. Again, you could tidy that up and maybe write B plus D minus A. And the last one, so we're going from T to S. So let's have a look. We're going from here to here. So want to use vectors that I know. So looking at this, it's probably best to take that path, because this is the last one. That is going to be T to R, R to Q, and then Q to P. And you know, the tip with this is the points that you're going from and to have to be at the end. And what you find is the letters cancel each other out, and that's how you know your path is correct. So what have we got? Oops, can't go that high. So T to R, going in the opposite direction of that vector, so it's minus D. R to Q, again going in the opposite direction, so it's minus B. And Q to P is plus A. So I would write that as A minus B minus D. Okay. Right, so let's have a look at the type of problem that it might give you when they give you a regular shape. So here we've got a regular hexagon. Apologise for the drawing, but please, it is a regular hexagon. And we want to find the vector AM. So we want to go from there to there. So let's just think about some basic paths. Most basic path of all is going to do that. But that would mean I need to work out what AB is and then BM. But I think we'll probably be able to do that. So let's have a go. So let's have a think. I'm going to say, I'm going to try and do AM is AB plus BM. Okay, so first we've got to work out what AB is. Well, to go from A to B, I could go A to D, D to C, and then C to B, and I know all those vectors, so that's fantastic. So I can write them down. So let's do it. So AB is going to be 2A minus B, because I'm going in that opposite direction. And again, I'm going minus A because I'm coming back from C to B. And so that becomes A minus B. And sometimes people actually write it on. So they might put on there that that is A minus B. Okay. Right, next bit. So we're going to go B to M. But because this is a regular hexagon, and again, I appreciate it's not drawn very well, but hopefully you should be able to see that that point there is at the midpoint because of symmetry. If you think hexagons are symmetrical along that centre line, so that is going to be the midpoint. So in fact, BM is going to be a half of BF because you're just going halfway down the line. So we want to work out what our BF is. So I'm going to choose a different colour. I'm going to come over here and we're going to go BF. Well, let's think, how can we do BF? To go from B to F, excuse me, I could go B to C, C to D, D to E, and E to F, which isn't great. So I'm not going to do that actually because too many things I don't know. So actually, could I just do that and that? Now, looking at that to begin with, you might think, but I only know one of those vectors. But in actual fact, we don't, because we've got this over here. And because it is a regular hexagon, this is going to be parallel to this. It's also going to be the same length. And therefore, they are actually going to be the same vector. So let's get rid of all these highlighters for a second. So in actual fact, I can write that that is the vector B. The same would go for FE, going from F to E. I could say that is A. And also E to D is parallel as A to B. So in actual fact, I can write that that's A minus B. So let's have a look. B to F. So in fact, I am going to go B to A plus A to F. We know B to A. Now it's in the opposite direction. So it's going to be minus A minus B. A to F is B. Sort out this bracket. It's going to be minus A. Now don't forget this minus times a minus makes a plus. And plus the other B. And so we're going to end up with 2B minus A. So I've worked out what BF is. Right, I'm going to scroll up a little bit now. Back to the original problem then. So we want to do what BM is. And we've said BM is a half of BF. So that's going to be a half of 2B minus A. So going from B to M is going to be B minus a half of A. Okay. And what was all this for? Well, the original question was to find AM. And we said AM was AB plus BM. So back to the final question. So here we go. So AM was AB, which is A minus B from up here, plus BM. So we've got to add B minus a half A. So I've got take away B, add B, so they disappear. I've got an A minus a half of A. So my answer is a half of A. And that makes perfect sense because we know it's in the direction of A. So it has to be some multiple of A. And what it's told us is this point M effectively is a quarter of a way down the line A to D. So from here to here is a half A. Okay, if you could go to exercise 11A now, or if after we finish this video, go to exercise 11A and have a go, that'd be brilliant. But before we do, I just wanted to finish off with one last quick thing with vectors. So, we need to do a thing called the unit vector. So before we do that, again, quick recap. We've got the vector A, which is 3 minus 4j. So let's just draw it over here. So I've got going 3i minus 4j. So the vector is going to go something like that, okay? And we want to find the magnitude of A. Now I wanted to recap a way that they can write this. They can do that by saying find A with 2 lines either side of the letter, and that just means the magnitude of A. And as we've done before, we know we can use Pythagoras, and so the magnitude of A is simply the square root of 3 squared plus 4 squared, classic 3, 4, 5 triangle, so it's got a length or a magnitude of 5. The other thing they can do is they can ask you for the direction, but if they ask you the direction, they have to tell you relative to what. So they might say, measure the direction of A compared to the x-axis or compared to positive j or something. So in this case, we'll do it compared to the x-axis, so I want that angle there. I know that's a 4 and that's a 3, so I can just say tan theta equals 4 over 3 and just find the angle. Now, the last thing they can do is they can ask for a unit vector, okay? So I've got a different vector here. I've got the vector A is 3i plus 4j. And we've got to think what they mean by the unit vector. The vector 3i plus 4j has got a magnitude of 5. And the unit vector is a vector in the direction of A with a magnitude of 1. So what they want is they want a vector that goes in the same direction as A, but its magnitude, its length is 1. We know A has got a length of 5. So how do we find a vector which has got a length of 1? Well, actually, we just divide each of the elements of the vector by 5. So what we actually find is, in this case, the unit vector for this is going to be 3/5 I plus 4/5 J. Okay, because you just divide it by the magnitude. And in a general case, the best way to say it is that the unit vector, trying to squeeze it in, is equal to the vector itself divided by the magnitude of the vector. So you take each of the term in the vector and divide it by the magnitude of the vector. Okay, and so when you finish that now, also go and have a look at exercise 11C and do the questions there. Okay, thank you. Bye.